Hello, and welcome to your video all about, we're still continuing with frequency distributions, but today it's all about central tendency. And so what is the measures of central tendency? These are very common descriptive statistics that we tend to start with when we are talking about our data or the study and using the data from that study. These are values that help us understand the center of a set of data, hence the name, measures of central tendency. They describe a set of data by locating the middle region of the set, provide a number that is representative of a group of data. This is frequently what we call averages. And there are 4 measures that we're going to talk about today. First, this one is a very common one that I think a lot of you are familiar with, and we call it the mean. But this is typically what you've known as the average when we talk about like the average scores of a test grade. That is what is actually the mean. So when we talk about in that way, we actually mean the mean. And this is the average that is found by summing the data. So you add up all of the numbers in your data set, and then you divide that total by the number of data values that you have. So it'll make more sense, I think, when we do an example. This right here, if you look at this formula, this is what we call the formula for the mean. But let me just explain what this means, and you don't even have to memorize this. This is what we call the summation. This is a summation symbol. And what it says is we're going to add up all of our x's, meaning we add up all of our data values. And then n is always the number of data values that you have. How many data values did you collect? And that is what we divide by. When we talk about the mean of a sample, we use this symbol, the x bar. That's the mean of a sample. The mean of a population is this Greek symbol that we call mu. All right? But you do your average the same. So when you're finding the mean, it's the same formula regardless of whether it came from a sample or the population. So here's a couple of examples we're going to do. Rosa scored 80, 70, 60, 85, and 55 on her science test. Find the mean score. The formula that we just talked about says that the first thing we do is we add up all of our data values. So I'm going to add up every single number from our data set. Okay, so that's the first thing we're going to do. And then, actually, we'll go ahead and add that first before I move on. That gives us 350. But then I'm going to go back up to here. Look at our formula. It says now you divide by how many data values you have. Well, in this example, how many data values do we have? 1, 2, 3, 4, 5. I take the 350 and I divide that by 5. And that gives us 70, meaning the mean or the average score of her science test is a 70. Look at number 2. John scores are 69, 79, 70, and 52. What grade does he need on his final exam to get a C average? Now, this is assuming that the final exam has the same weight as the test scores. If it didn't, then we would not be able to use just this way. We would have to use another formula. But let's start here. How do we figure this out? Well, the mean says we add up all of the values. However, we don't know the grade on the final yet. That's what we have to find. I'm going to call that X. You can call it whatever you want, but I'm going to call it X. That's our missing value because the question is, what grade does he need on that final exam that when we add all of these up and we find the mean, we get a 70. Now we're going to divide all of that by 1, 2, 3, 4, 5. 5 tests in total, which includes the final. We need that mean, that average, to be a C, which means a minimum of a 70. Okay. So we're going to have to do some algebra here. Let's see. The next thing we want to do is we want to get all of this by itself. Notice you have the 5 in the denominator. we want to get rid of that over here and bring it to the right-hand side. Since we are dividing by 5, we're going to do the opposite. We're going to multiply by 5, because that way we took it from the left-hand side and brought it over to the right-hand side. What does that leave us on the left-hand side? Add these 4 numbers together. We're just going to add these up, and that gives us 270 plus the x. Don't forget, we can't do anything there yet. So we added these 4 numbers, which gave us 270 plus the x equals, and then the right-hand side, 70 times 5 is 350. All right, so we have that, but now we need to solve for x. Notice we're adding here. So and the 270 is positive, so we need the x by itself. That means to solve for x, I'm going to subtract both sides by the 270. That way, remember those just cancel out. I have x, let me slide this up a little bit. X equals, and now subtract those 2 numbers, and we get 80. Meaning, for John to get a 70 average in this class, he would have to get at least an 80% on his final exam. All right, now let's talk about another type of central tendency, measure of central tendency. That would be the median. The median is the value in the middle of a set. This value divides the set basically into 2 parts. It divides the data into halves, 2 halves. 50% of the numbers are going to be below the median. 50% of the numbers will be above the median. Here's the thing though, to find the actual middle number, you're going to have to put these numbers in order from the smallest to the largest, and then you find the middle term. So let's go here, and then I'm going to show you, well, let's just start with number 1, then I'll explain number 2. We want to find the median of these numbers. However, we need to put them in order from smallest to largest. So I see 2 1s, and yes, you write out every number, even if they repeat. I see 2 3s, 1 4, a 6, 2 8s, oops, and a 9. So now I have all of these in order, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. What number is in the exact middle of this data set? That would be this number right here, the number 4. Because now notice you have 4 numbers to the left of 4, 4 numbers to the right of 4. So now this number splits the data into 2 equal halves. So 50% are below, 50% are above. But let's go to the next example. It says find the median of these 4 numbers. So let's put them in order first. They were almost there, but the 91 needs to go before the 95. Okay, we have an even number of data values. So there isn't a number from the data set that is exactly in the middle. Here's what we do, and this is where I'm going to go up here, look up here in the note. See this? If there is an even number of values, then what you do is you have to find the 2 middle values and then find their mean. All right, so let me kind of explain. So looking at these 4 numbers, the 2 middle numbers would be these 2 numbers, right? 86 and 91. Find the mean of those numbers. That means I add these 2 numbers, 86 plus 91, and then divide by 2. That's going to tell me the middle number, which is the mean. Median, sorry, not the mean. We're finding the mean of these 2 numbers, and that's going to give us 88.5. That means that the mean of this data set is 88.5, and that is technically the number here that would be in the exact middle of the data set. So with the median, if you have an odd number of data values, then it's just that middle number. If you have an even number, then you're going to have to find the 2 middle numbers and find the mean of those 2 numbers. All right, let's keep moving on. The next central tendency or measure of central tendency is mode. This one, in my opinion, is the easiest one. All you have to do is find the score that is the most frequent score, meaning it has the highest frequency. That is your mode. Now your mode, you can have more than one mode, by the way. You can have no mode. So let's look at letter A. Which number here in this data set occurs the most times? Looking here, it looks like the 70. That occurs 3 times. So 70 would be the mode for this value set. Look at letter B. I see the 8 occurs twice. I don't see anything else that occurs more than that. So 8 would be my mode. Letter C, we have 3, 2, 1, 3, 2, 6, 8. And it looks like here, oh, notice here, I'm gonna underline here. The 3 occurs twice, but the 2 also occurs twice. That means that you have 2 modes, the 2 and the 3. Those are your modes for the data set because they both have the highest frequency and the same frequency. Look at D. 99, 100, 103, 89. No number here occurs more than the other. So with this data set, there is no mode. All right, and that's it for the mode. The mode, like I said, it's not too bad because we're working on, you're just looking at what occurs the most frequently. All right, now we're going to look at an example here. We often deal with weighted means in which different data values carry different weights in the calculation of the mean. For example, if the final exam counts for 50% of your final grade and 2 midterms each count for 25%, then you have to assign weights of 25% and 50%. All right, so I'm going to skip down because we are going to talk about weights, but weights when it comes to your GPA. Here's an example from a school. Apply the idea of weighted mean in the following exercise. A student has completed 15 credits in the table to the right during 1 semester. Grades are weighted so that an A would be 4.0, A minus would be a 3.7, all the way down to where a C would have a weight of a 2.0. Look up here in the above graph or table over here. This table is showing you the students' grades and how many credits that they received for that grade. Because credits makes a difference when we're talking about also the GPA. All right, so we're going to go down here, and what we want to do is figure out the student's GPA. So first of all, we've got the course. I'm going to abbreviate for all of these because I just don't want to waste too much time with that part. So notice I'm doing a lot of abbreviations there. I'm just writing down, and then I'm going to put Geo Lab. There we go. All right. Now I'm going to write here the credits. Go up back to your table up here. In that middle column, you can see my mouse here. That is the credits. So all I'm doing right now is taking that table and writing down the values. And same thing with the grade. Over here, we've got a grade, and I'm going to write that down because all we're doing right now is organizing our data. Now, we're going to put in the weight. You're going to have to go back to this paragraph where it talks about the weight, a B minus. So I look back up here, and a B minus has a weight of 2.7. Again, just going up here to look at the chart. The weight of a B is 3.0. A C is a 2.0. A minus, let's look up there. A minus is 3.7. And then B, we already did that one, 3.0. All right, now we take the credits and you multiply that by the weight. So that's the next step, not the last step. We're still going to do other things, but we're going to take each credit and multiply each credit times the weight, okay? And so that gives me 10.8. Then we're going to take the 3.0, the weights. Oops, nope, 4 credits that was. So let me undo that. Okay, That was 4 credits and then times the 3. So that's 12. Then we have 3 credits for French, and that was a C with a weight of a 2.0 or just 2. That gives me 6. Let's see, we have 3 credits times an A minus, which is a 3.7. That's 11.1. And then last but not least, the lab is 1 credit, and that was a 3, which gives us 3. Okay. Now, what we want to do is we want to add all of that together, okay? Meaning we're going to add all of this. We want to add the credits plus the weight. So add all of these numbers that we just found. And we should get 42.9. Okay, so I'm going to go over here because the question was, what is the GPA? The GPA is going to be, oh, and how many credits altogether? It already told us, but if you add up these credits, we get 15. The GPA is going to be the total in the column of the credits times the weight divided by the total credits. What we do here then is we take the 42.9 divided by the 15, because that's the total credits that we have. So you take these two totals, divide it, and then let's round to the nearest hundredth, so 2 places. On my calculator, I am seeing 2.86. So the student's GPA would be about a 2.86. Now let's go to B. What grade would the student need to earn in French? So let me just change my colors. To raise her GPA over a 3.5. Okay, so we don't know. In other words, we're going to change this. We're going to say, what does she need in French? Take away that C, meaning we don't know what it is now. We know everything else. We're going to assume that everything else stays the same. If that's the case, the 10.8, I'm just going back, so let me just show you where I'm going back. I'm going back to this. Actually, I'll keep that up since it fits in the screen. I'm going back and adding up our credits times the weights, except I'm stopping where the French is, and I did not stop, did I? Let me go back. There we go. So I did the stats, the Eastern religion. Now I'm stopping where the French is. We know that it's 3 credits times, but we're going to put an X here because we don't know the grade. We want to know what grade would need to be earned to get a GPA over 3.05. All right, so we're just going to make that an X. Now I'm going to keep going because in the other ones we're assuming that we're keeping all of that. And then we're dividing, remember, we divide all of that by 15. Okay, let's keep going. I'm going to add these 4 numbers, but leave the 3x. So add all of the numbers, but not the 3x. So if I add up all those numbers, we get 36.9 plus the 3x. Can't add those with the numbers. Divided by 15. What do we want this to be? We want this to be at least a 3.05. Okay, so I'll just put 3.05. And we want to make sure the grade's going to go over that, but we're going to keep it right here, right where while we're solving. We're going back to solving for x. So the first thing we need to do is get rid of the 15 on this side. So you're going to multiply both sides by 15. Okay? Multiply both sides by 15. So what I have left on the left-hand side is this. And then on the right-hand side, you're multiplying that together. That gives us 45.75. We're still trying to solve for x. So now that means I'm going to subtract. Yeah, this is a lot. This is taking you now back to algebra. Okay, so now we're going to subtract on both sides. Oh, fortunately, I have a good amount of room here. That means I have 3x equals, and subtract those 2 numbers, 8.85. We're still not done. We have to solve for x. So now I need to divide by what's in front of the x, which is a 3. divide both sides. So now we have x equals, now divide these two numbers on your calculator, and we get 2.95. All right, so here's the thing. The weight needed from the grade in French is a 2.95. However, let's go back up here. Whoop, right up here to see if you can see where my mouse is, where it talks about what the weights are. There isn't a 2.95. There is not a 2.95. What is the closest that we can get to for that? Right here, a B of a 3.0. So the minimum grade to be earned can't be a 2.95. It would have to be at least a 3.0. And then that way we can get our weight to where in French she will obtain a GPA of 3.05 or higher, but at least a 3.05. All right, so that one had a lot of algebra in there. That'll give you good practice. But that ends our video then on measures of central tendency.